Welcome to the Cadenza ICASSP 2026 Signal Processing Grand Challenge. It's all about predicting lyric intelligibility. My name's Trevor Cox, one of the Cadenza team, and you'll see a QR code there and also a URL if you want to go to our website and find out much more about the challenge. So why are we running this challenge? Well, Cadenza is trying to improve music for those who have a hearing loss. And that's a large number of people. The World Health Organization has that at 1.5 billion people currently, and it's growing because the population is aging and more people are exposed to loud sound. Now, something that several studies have shown is that people with hearing loss can find it harder to pick out lyrics. And of course, lyrics are important to lots of types of music for our enjoyment that we get from listening. Now, if we look at a field like speech, there's been speech intelligibility metrics for many decades. I'm thinking, you go back to STI, but I'm thinking here of Story and ICASSP, which have been around some time. And these have underpinned advancements in speech enhancements and noise reduction for speech. And especially if you think about things around machine learning. There's also been challenges recently that have been trying to run and improve prediction approaches. And I'm thinking here of the clarity challenges and the recent CPC3. And during that time, we've emerged new approaches to speech intelligibility prediction based on ASR, models like Whisper and WaveLM, for example. So there's lots of work on speech intelligibility prediction, but then you look at lyrics and you find there's virtually nothing. So the interesting thing for me, and if I was a researcher wanting to do this, is it's really quite an open field. There's lots of different things you can learn from speech intelligibility work, or you might look at automatic lyric transcription work or other areas. And not much work has been done. So you've got a chance of doing some real interesting novel research. And lyrics are not the same as speech. How we sing words is not the same as when we speak them. There's differences in the accompaniment, the sort of background noise you're working against, and there's differences in sort of kind of how the sounds are processed. So if you take a recording of a vocalist, it will normally have reverb and chorus and dynamic range compression on and other effects as well to make it sound better. So there's lots of interesting differences for you to tease out and play around with if you wish to. So what is the scenario? Well, imagine a listener sitting down and listening to a short snippet of music. We'll call that audio 1. They're asked to write down the words that they heard. From that, we calculate the speech intelligibility, which is the fraction of words in the lyrics correctly identified. That's the target. So your task is to predict that target, the speech intelligibility, from the music they heard, audio 1. Now, there's some other data sloshing around, and we'll come to that in a moment. But that, broadly speaking, is a broad brush view of the problem that you're trying to solve. Now, as I mentioned earlier, Cadenza is all about listeners with hearing loss. You might think about trying to do this challenge just by the music that is just coming out of databases. But an awful lot of people are listening and going around listening to music and they have hearing loss and they're not necessarily wearing hearing aids. So as well as the audio being the original music, we've also simulated mild and moderate hearing loss to sort of kind of simulate what would happen if we had a listener in the room who isn't got perfect hearing. And that represents a much greater percentage of the population who listen to music. Now, our listeners had no hearing loss, so they're just listening to the simulation of hearing loss in these cases. That was done by a Cambridge model. You can find that on the PyClarity GitHub if you want to kind of play around with it. But what I would say at this point is you don't have to if you don't want to. You can just treat this audio as degraded audio in the same way as you might in speech intelligibility deal with speech as degraded speech. The fact we degraded it with a hearing loss model is just a different kind of degradation to what you might do if you just added some additive noise. So you don't really need to know too much about hearing loss to do this challenge. You can just treat this audio as is, really. So let's hear what the hearing loss simulation does. So here's a piece of music as original. Truly alone, I am truly alone. And let's add some hearing loss. Truly alone, I am truly alone. So audio, some degraded audio to play around with. The second is obviously slightly less intelligible. So I'm going to talk about how the data was generated, and out of that will emerge why you've got a bit more data than just audio 1 to work with. And you'll see there's actually 4 bits of metadata, 5 to 6 bits of metadata listed down here, and audio. So I'll come back to what that is in a second. So we started off with the FMA database. That's a lot of music. We filtered it out to get ones which didn't have the right license or didn't have English lyrics, and so kind of things we had to exclude it. If you want the details, a lot of them up on our website, but I'm going to kind of skip past some of the details there. But essentially, we took a set of good tracks and we extracted a chorus and a verse for each one to work with. We then needed to know the ground truth. What were the lyrics? Now, sometimes you can look those up online, but for most of FMA, the actual transcripts don't arise, so we can't find them. So we have to get humans to annotate them. So we had an annotation process using Label Studio to come up with the ground truth correct lyrics. So the first bit of metadata I haven't mentioned already is the ground truth text. So you have that available to you in your experiments. In terms of audio, it's coming down the line and it's going to go to a listener here in a listening test. But we have it first of all going through hearing loss simulation. So you'll notice there's a skip connection because some of our audio hasn't got hearing loss, and you'll notice that some of it goes to a hearing loss simulation. So it has sometimes have hearing loss. So we have no loss, mild loss, moderate loss. And that's what the hearing loss severity is, and that's what the hearing loss severity metadata says. The hearing loss simulation, I think I mentioned earlier on, is the Cambridge model. There's audiograms behind it, but we don't provide those. We just give the severity that we've applied. So the listener then listens to a track, this piece of audio. We called it audio 1, which is what we've provided you already to play with. And then they just type what they heard. And that gives a transcript, which we also give you, and then an intelligibility score, which is the target you're trying to get to. Now, when we're looking at this, we also, you'll see, gives you audio 2, which is the original track without any hearing loss simulation in it. That's because in our scenario that exists, and there are reasons why you might want to use it. And when I explain the baseline, and you see the baseline on the website later on, you'll see that it's being used. So it's a useful piece of audio that we provide, and we'll go into that a bit more in a different video. Now, of course, we may not have hearing loss simulation for a third of the tracks. So audio 2 and audio 1 for a third of the tracks are actually the same, but for 2/3 they're different. So that's the reason we have audio 2, and we'll go into that in a bit more detail later on. So if we were to look at actually the metadata, or sort of which is listed, you'll see that we have a signal. That's audio 1. Effectively, that's the code for the audio 1 file. You have the prompt, which is the ground truth. So the actual lyrics were, in my mind, I can see is fine in this case. The response is the transcript that the person typed in the listening test. Now, when you see a hash, that means they got no words at all correct. I mean, normally there'll be some words there, but there's lots of cases where the words weren't intelligible, and that's not unusual. And when you look at the data, you'll find there's quite a lot of intelligibility equals 0 scores. A number of words in the prompt, words correct, and the correctness, which is the fraction of words which were correctly typed. Obviously, those are both 0 because they've got nothing here, and then you've got the hearing loss. So that's kind of metadata we provide. When you go and look at the actual data, you're going to be available for eval, which is what you'll get scored on in the end. Obviously, not all of it's there. We don't tell you the correctness, the words correct, or the response, because that's what you're trying to do, is predict what people actually did. So you'll have some of the data, but not all of it. And if you go to our website, you'll see the rules. It'll tell you what's available and what's not available when it comes to eval. So what about timelines? Well, we've just launched. A key deadline is 1st of December. That's when the challenge closes. We release evaluation data nearer that deadline in November. So what you need to be thinking of and working towards submitting before the 1st or on the 1st of December. Now, the best teams get to submit a paper for ICASSP 2026, and then we end up in the end going to a special session in Barcelona at ICASSP, where we can discuss the different approaches people did to lyric intelligibility prediction. Now, you don't have to go to ICASSP if there's some reason, visa reasons or something you can't get there. That's fine. We welcome entries from everyone, but it's great, obviously, if more people can get to Barcelona. So we have a great session there as well. So if you want to know more, and I better move myself out of the way, otherwise you won't be able to get this, you can use the QR code, or you can go to that URL where you'll find lots on the data and the rules and other stuff up there. And if you've got any questions, please do get in touch. We're really keen to help. We're a team that wants to get as many entrants as possible. So please do get in touch with us. Register for the challenge. Get onto our Google group. Start discussions so we can have a really great ICASSP challenge.